Let's look at the theories of acids and bases. First theory is called Arrhenius Theory. That is means simply if H plus is released into aqueous solutions or in the water, and that is called Arrhenius acid, right? So the Arrhenius acid releases protons into the water. Good example is hydrochloric acid. It will dissociate or break into protons, H plus, hydrogen ions in the water. So therefore it's an Arrhenius acid. So HCl qualifies to be an Arrhenius acid, right? Okay. Now let's look at Arrhenius bases. So Arrhenius bases should have hydroxide ions released into the water. So if you take sodium hydroxide, it will dissociate or break into sodium plus and hydroxide ions. AQ means in the water. So it releases. So this hydroxide ions released into the water qualifies sodium hydroxide as a Arrhenius base. So you can actually see in the sodium hydroxide, right? And also it's released into the water by, we call the dissociation to the aqueous solution, right? So those are the two examples, Arrhenius acid and Arrhenius base. Now, let's look at this one. This molecule is called ammonia. NH3 is a covalent molecule. It's called ammonia. If it reacts with water, water can be written like this way, so for clarity, and these two lone pairs takes this proton, okay, and it breaks the bond between the hydrogen and the oxygen, this bond, and the both electrons are given to oxygen, and it will break partially. This double arrow means it's partial dissociation, but still it's going to make ammonia plus H plus, and then release a hydroxide from the water. So there is a hydroxide and an ammonium, NH4 plus, in the water. So in this situation, ammonia doesn't seem to be having a hydroxide the way the Arrhenius base is shown. So now what has happened, ammonia reacted with water and releasing hydroxide and an ammonium ion, NH4 plus, and a OH negative, right? That's what is released. Now, so now we can look at ammonia did not show any hydroxide ions to release to the water. That's a question, right? So this is actually can be answered using the next theory. Theory 2 is we called Bronsted and Lowery theories. Bronsted and Lowery theory. And so Bronsted and Lowery theory also, we have a short form, we call it BL theory. Okay, so let's look at how do we explain using BL theory this ammonia and water reaction, giving you ammonium ions and the hydroxide ion, right? So that can be explained. So based on the BL theory, what's the explanation is for, let's look at water first. Okay, so when we look at water, water has what the water has done is take or give away a proton. So it's a proton donor. Water is the proton donor in this reaction. It give away the proton, right? So that's the BL theory acid. Now what's the BL theory base is the proton acceptor. Ammonia accepted the proton. So based on the BL theory, ammonia is the proton acceptor and water is the proton donor. So that's how we explain the BL theory. So this water becomes BL acid and ammonia becomes the BL base.